In this video, I'm going to show you how to remove a node by its index. For this method, I'm going to call it remove. Remove will take in one argument, and that will be the index or the location of the node within our list that we want to remove. And we want to take care of three edge cases. The first one is to check if the index is out of bounds. So what I'm going to do is I'm going to copy this edge case from our insert method and paste it inside the remove. There's going to be one tweak, however, with this one. We are going to have to add if for this condition here, we are going to check if the index is greater than or equal to this dot length. So that minor tweak there to check if it's greater than or equal to. And the reason for that is because this list here that we have built out there looks like this. So 7, 5, and 19. So if I was to, we know that this is a length of 3, right? Looking at this, that's a length of 3, right? So that's this length right here. And if we were to pass as an argument an index of 3, so another 3. So is index if 3 is 3 greater than or equal to 3? All right, that's pretty much how this condition is being stated. So this is the index. So we know that this list starts at 0. So this would be 0, and then the 5, 1, 2, and then 3. So 3 would be in this place over here, which is non-existent here. So in that case, for that reason, we also want to say is the length of 3 that the index of 3, if it's greater than or equal to the length, which is 3, in that case we want the condition to be that condition would be true, so it would return undefined. So just make sure that you add this greater than or equal to. All right, I'm going to remove this here, all right, so let's go ahead and continue. So the next edge case is check if the index let's go back, and the edge case is check if the index is equal to 0. Okay, so what I'm gonna do is say if the index is equal to 0, in that case we're gonna call a method that we have available to us already built, and that is the shift right here removes the first element from our list. So return this dot shift. All right, that takes care of the second edge case. The third and final edge case, check if the index is equal to the length minus 1. So if the index is equal to this dot length minus 1, then return this dot pop. Okay, again, don't let this confuse you with the minus 1. The reason is because remember that we're starting with an index of 0 when we're going through the list. So for that reason, in order to refer to the last or the tail node of the list, we have to include the minus 1. All right, so don't let that trip you up. All right, it's because the list we're starting at an index of 0. So in that case, the pop method, which we have built earlier, which is this one right here, will remove the very last node from our list. All right, so that takes care of our edge cases. All right, so now let's go ahead and set up some variables. We're going to set up the previous and the current nodes. Do previous node equals, set it by default, set it to null. And then we're going to set the current node to be this dot head. Okay, so this is our list right here. So the previous would be, before we even get started, by setting this up like here, what we're doing is that the current node right now is at the head. So you can imagine that it's placed, a current node is, a pointer is below this 7, and the previous is one position behind over here, pointing pretty much nothing. It's pointing to nothing. It's currently pointing at nothing. But as we advance or go through the loop, each advancement or each iteration of the loop, it would those 2 pointers, these 2 pointers here, would advance forward 1 position. So then the previous node will start pointing at the 7, and then the current node will point to the 5, and then that continuation or that process will continue on until either we find a node or it reaches the very end, in which case we never found the index, or the index was never the correct index was never there. But in either case, that shouldn't happen. You should never arrive to the point where it reaches the very end, because this edge case at the very beginning takes care of that instance or that edge case if that issue was to arise. All right. So now that we took care of that, let's go ahead and set up our loop, which is right here, and we're going to do an if else block, and we're going to check if the loop index is, or let's set up our loop. I'm not going to do a while loop. I'm going to do a for loop this time. So I'm going to do for let I, the starting index for the loop is 0, and if I is less than this dot length, we can enter the loop, and each iteration we want to increment the index by 1. All right, so now that we set up our for loop, if we get to this, so the if statement says if the loop index is not equal to the argument index. So if the loop index, which is here, so if I is not equal to the argument index passed in here, that means that we have yet to arrive to the position within our list that we're trying to make the removal from. So in that case, we want to make updates on these 2 variables. So the first one for the previous node, we're going to make that now become the current node. And then the current node will now become the current node dot next. All right, so these 2 statements here advances both the pointers 1 position forward. All right, so now here in the else block, if we arrive here, then that means that we did indeed arrive to the location within our list that we want to make that removal from. So that is over here, our else block. The first thing we want to do is make previous node point to the current node's next node. All right, so that is kind of like if we were to say, now, like, so we have this list here. So let's say I have a list, I had do list.remove, and I want to remove this one right here, which would be at index number 1. All right, so if I pass in 1, I mean the position number 1, that would indicate I want to remove 5 here. So in order to, going back to this statement here, if we look at this like a sentence, we're saying remove the previous node, make the previous node point to the current node's next property. So this is the previous node 7, and this is the current node right here, right? Because the else block is pretty much stops here, because the current node, the index of the current node matches it. The else block is pretty much arrives here, where the index is 5 and the previous node is 7. So what we want to do is point this 7, point it to the current node's next property, which is the 19. So we are saying to now here, point the 7 to 19 right here. That is what this statement is saying. Make the previous node point to the current node's next node. And that is how we're going to end up with this here, just based off this statement here. Make the previous node point to the next node's next the current node's next property. And the way we're going to write that out here in code is the previous node dot next will now point to or become or point to the current node's next property. All right, so that takes care of that removal. And then because we are removing an element, we are going to have to decrement. So we're going to do this dot length minus, and then we're going to return this, or return the new list. And then after this for loop, we're going to return false. All right, so let me draw out this list again, the way it's over here. That's the way it is. And then with this remove statement, once I call it, it's going to remove the 5 and just have 7 and 19. So let me show you. So let's go ahead and test this out. If I run this code, expand, you see we get a length of 2. So that's a good sign so far, right? And let's look at expand this, and we see that the head here is 7 here. And what does that 7 point to? If I expand this, look at here, it's pointing to 19. So it's pointing to this thing here. So it didn't point to the 5, so that means it did indeed remove the 5. So now it's like this. And if I expand that that node with 19, the last one, it should point to nothing, which you see here, next null. All right, good. That's working. Let's go ahead and quickly check our edge cases. Make sure that check if we pass in an index that's out of bounds. So let's pass in a negative. Let's do -2. I'm gonna save and run the code. Okay, I got an error here. Oh, okay. Remove. There we go. Okay, what happened? Okay, so let's try that again. Run the code, and you see undefined. So I ran this block of code here, which returned undefined. Let's do something greater than or equal to the index. So let me do let me just do 5. It should return undefined. You see undefined. How about this next edge case? Check if the index is equal to 0. In that case, you should remove the first element here, which is 7. So let me go let me pass in. Okay, let me start this here. So right now, let's restart this here, draw this out. So 7, 5, and 19. So if I want to pass in 0, which is this edge case here, is going to remove the first element, which is a 7. So let's check that out. Run the code. Oh, no, what am I doing? Not push that. 7, 5, and 19. And then now I want to do list dot remove and at index 0. So clear this up, run the code again, and let's see, we got a length of 2. Okay, If I expand this here, you see that the head is 5. So remember, so I removed the 7. So now the head is 5, and the head is pointing to 19, which is here. All right, good. So the second edge case test passed. How about the second one? If the index is equal to this dot length minus 1. So referring to this one here. Let's go ahead and remove, let's see, so this is index 0, index 1, and then index 2. So let's remove index 2. Save and run, and length of 2, that's good. If we look at the head, that's 7, and you look at the tail is now 5 here. So the tail is no longer than 19, it's 5. So there you go. So we have a functional remove method that removes a node from a linked list.